Okay, this is going to be an example of the Ford Fulkerson algorithm for finding max flow on a network. Here we got a bunch of nodes with edges. Notice the arrows are pointing in the direction that the edges go. Quick thing, very important here. Each edge has two numbers. On the right side, the right number is going to be the max capacity of that edge, and the left number is going to be the flow going through that edge. So obviously before we start, as we can see, the flow on every edge is 0, but every edge does have its maximum capacity. Okay, so to begin here, we are going to pick a random path, whatever path. Every path, the only restriction is that it must go from A to Z. A is the source and Z is the sink. So let's see, we'll pick A, B, D, and Z. That is A, B, D, and Z. We're going to write our path over here. Always helps to keep track. Okay. Now that we've picked our first path, we have to find the bottleneck. Now, how do you find the bottleneck? Let's look here. The bottleneck is going to be the minimum number, the minimum capacity number out of this path. So our capacity numbers are 8, 6, and 10. Minimum out of that is 6. So the bottleneck is 6. What are we going to do now? We're going to replace the flow of every single one of these with 6. Now what does that mean? It means that through this path, the maximum flow we can get is 6. And intuitively this makes sense, because if this edge can only carry a maximum of 6, then even if we try to put 8 through it, we're not going to get 8 through. It can only take 6. So 6 is going to be the bottleneck. That is what is going to go through this path and get to the sink at the end. Okay, the next step is going to be simply pick another path. We can do a I, J, K, and Z. That is A, I, J, K, and Z. Okay, just like last time, we are going to find the bottleneck of our path. So comparing 6, 8, 12, and 14, 6 is obviously the smallest. That is our bottleneck. So that is going to be the maximum flow we're going to get through here. We're going to go ahead and replace our flow on all of these with 6. Just like that. There we go. Okay. Well, next step, pick another path. We're going to go with what? I'm picking at random, by the way, completely random. A, G, H, D, Z. That's what we're going to go with. A, G, H, D, and Z. Just like all the other times, we're going to find our bottleneck. That is 9, 7, 7. And here we come to a new situation, right? Unlike all the other times where we always had a flow of 0 going through everything, notice here we have a flow of 6, right? So the only thing this affects is how we decide our bottleneck. So normally we would find the minimum number of capacity between all of these, right? And that would be our flow. Now, that's not going to be the case here anymore. Now we're going to take, whenever we don't have a 0 here of flow, we're going to take the difference between the capacity and the flow of that edge. That is to say 10 minus 6, 4, right? So now we're going to use 9, as usual, the capacity, 7, because there's a 0 here, 7, because there's a 0 on this edge, but here it's 4, okay? So out of all those numbers, 4 is our bottleneck, because it is the minimum. So we're going to go ahead and replace all of our flows with 4. 4 here, 4 here, 4 here, and here we don't replace 6 with 4, we sum them, because intuitively this makes sense. We're getting 6 through this top side. That was the first path we did. And now we're going to get another 4 through this new path. So that's 6 plus 4 of flow. That gives us 10 flow. Notice this is completely saturated. That is to say, we cannot get any more flow through this. So from now on, we're going to want to pick paths that take us through this edge, the KZ edge, because we have 6 flow but 14 capacity. That gives us 8 left over to work with. Okay. Right, now we're going to pick another path. Let's see. We could go A to G to I to J to K to Z. Yeah, that'll work. A to G to I to J to K to Z. Okay, just like before, keeping in mind that we have non-zero values in the flows and that we need to take the difference of the capacity to the flow to calculate our potential bottleneck there. We're gonna find our bottleneck. So we got 9 minus 4 is 5. What do we say? A, G, I, J, K. Okay. 9 minus 4 is 5. Here we have 7 since we have flow 0. 8 minus 6 is 2. That's now our smallest. 12 minus 6 is 6. 14 minus 6. Okay. So our smallest, our bottleneck is going to be 2. That is between I and J. And then we're going to update here. 4 plus 2, 6. Here is going to be 2. 6 plus 2 is 8. We're topped out there. 8 and 8. Okay. Gotta pick another path. Let's see, what are we gonna pick? We can go A to B to H to K to Z. That is A, B, H, K, Z. Again, find our bottleneck. 9 minus 3. No, we said A to B, sorry. 8 minus 6. So we got a 2. We got a 7. 6. And then we got another 6 again. So our bottleneck is going to be here in the 2. So 6 plus 2 is going to be 8. Here we're going to replace with a 2. Same here. 2. And here we're going to go with 10. Okay. So we're going to have to make a path that goes from A to G. It has to start like that, because if we look here, we've already topped out our maximum flow here. We got 8 out of 8, and down here we got 6 out of 6. So we're all out of flow there. Okay, let's see. What can we do here? We can't go down this way, so that means we're going to have to go this way. So we're going to have to go A to G to H, and then from H, we can go down to K and then to Z again. Perfect. K to Z. Okay, so let's find our bottleneck. We got difference of 3 here, difference of 3, difference of 4, difference of 4. Okay, so our bottleneck is going to be 3. Perfect. Then we're going to go 6 plus 3 over here. That is going to be 9. 4 plus 3 is 7. 2 plus 3 is 5. And then over here, 10 plus 3 is 13. Okay, and now we're done. Why, you may ask? Well, a few things, right? So we can see we're topped out. We got 8 out of 8, 9 out of 9, 6 out of 6. We can't get any more flow through the system because our entrance is completely bogged down. Now to check that we got everything right, the sum of these is going to be the sum of these, right? So we got 8 plus 9 plus 6 is 23. 10 plus 13, that's 23. That means that our max flow is going to be 23. And that's that. Pretty simple algorithm. Just a matter of picking the paths and knowing the rules.